Check this out. I'm going to show you how I afforded this car.
The standard unit of information is the bit, which has a little bit of a funny or wordy. Sure, a little farther to the left happens about 14% of the time. And what you're hoping for when you make a guess is that you end up somewhere out in this long tail, like over here where there's only 18 possibilities for what matches this pattern that evidently look like this. Or if we venture a little farther to the left, maybe we go all the way over here. Okay, here's a good puzzle for you. What are the 3 words in the English language that start with a W, end with a Y, and have an R somewhere in them? Turns out the answers are, let's see, wordy, wormy, and Riley. So to judge how good this word is overall, we want some kind of...
I always think he says, like, Riley.
...of the expect... So to judge how good this word is overall, we want...
How good this word is overall. Oh.
Kind of measure of the expected amount of information that you're going to get from this distribution. If we go through each pattern and we multiply its probability of occurring times something that measures how informative it is, that can maybe give us an objective score.
Probability of occurring. So it seems like the name of the game here is, we've got our initial big sample space, and the smaller the probability, that it's going to happen like this, that's going to be a lot of information. So you would think that's a lot of information. Why not just use like the inverse probability, like the, I don't know, like 1 over the probability of X or something, then like smaller probability events get high information. Something like that.
Now, your first instinct for what that something should be might be the number of matches. You want to look for average number of matches, but instead might be the number of matches. You want to lower average number of matches, but instead.
What are we summing over here? Like, what's X?
To use a more universal measurement that we often ascribe to information, and one that will be more flexible once we have a different probability assigned to each of these 13,000 words for whether or not they're actually the answer. The standard unit of information is the bit, which has a little bit of a funny formula, but is really intuitive if we just look at examples. If you have an observation that cuts your space of possibilities in...
Let's see, log base 2 of P. So just curious,
if we just look at
the negative of log base 2 of P. So let's say if P is equal to 1, then the negative log base 2 of 1, 2 to the what is 1, so this is negative 0, which is equal to 0. So I guess there's no information there. And if, let's say P is equal to, let's just do 0.5. Negative log base 2 of 0.5. So it's 2 to the negative 1. So this is equal to negative 1, which is equal to 1. So the information would be 1. And then if we had P is equal to 0.25, that would be negative 2, right? 2 to the negative 2 is equal to 1 over 2 to the 2, 1 over 4. Yeah. So we would have negative log base 2 of 1 is equal to 0. Negative log base 2 of 0.5 is equal to 1. 0.25 is equal to 2. 0.125 is equal to 3. Or we could also just, instead of doing like this, we could do log base 2 of 1/2 and 1/4 and 1/8 and 1/16 of 4. 1 over 32 is equal to 5. So the smaller the probability, the higher the information.
If you have an observation that cuts your
Okay, happy with that for now. All right, peace.